I'm going to be doing a video over Newton's method, and basically it's just a way to approximate zero. So from the class notes we should have an equation that looks something like x sub I plus 1 is equal to x sub I minus f of xi over f prime of xi. One easy way that I like to think about it is that x sub I plus 1 is where we're going or what we're trying to get, and x sub I is where we've been or what we know. So from the review sheet that we had in class, we had an equation for f of x is equal to x squared minus 5, and we were given x1 is equal to 2, and we're trying to approximate the zero of that function, and we were told to go to x3. Alright, so to do that we need to start out by just taking the derivative, so that way we can have everything that we need to plug into the function. And when we take the derivative of the f of x, we get that the derivative of f of x is 2x. So now we have what we need to actually start using the equation that was listed before as x sub I plus 1 is equal to x sub I minus f of xi over the f prime of xi. Okay, so since we have our x1 right here, that is saying what we know or where we've been, and we were given that x1 is equal to 2, and we're trying to find x sub 2, which is x sub 1 plus 1. So x2 is where we're going, and x1 is where we've been. So now just plug in everything accordingly. Plug in x1 where you see a x1. If it's in the function or derivative, plug it in for there, and set up your equation to get ready to solve for x2. Okay, so whenever you set up the equation for x2, you should get something that looks like this, where our 2 here was our original x1, and then this was our f of x right here. So we see that 2 squared minus 5, because the 2 is substituted in for the x. And then on the bottom our f prime, 2x. Again, the 2 is being substituted in for the x. So whenever you make those calculations, you should get 2 minus 4 minus 5 over 4, and then just compute that as well. So when you compute that, you get 2 minus a negative 1/4. You see the 2 negatives, so that's going to make it a positive. But you should also notice that, oh no, we have a fraction and we have a whole number. Whatever shall we do? We'll need to find a common denominator for that. So whenever we get our common denominator, we get 8 over 4, which is 2, and our signs changed to positive, and we still have our 1/4. So whenever we solve that, since we have common denominators, we get 9 over 4, which is our x2. So now we just do the whole thing over again using 9 over 4 as our x2, and we will solve for x3. Okay, so set up the equation for x3 the same as before, but just keep in mind that our x2 was 9 over 4. So make the appropriate substitutions and set up your equation to begin your calculations. So this should be how your equation looks, and then just do the appropriate calculations. So once you make the calculations, it should look like this. Right up here where you have a fraction and it's being squared, you're going to actually take and do the squaring to both. So right down here, that's 9 squared is 81, and your 16 is your 4 squared. That's where that comes from. And since you have a fraction now, you need to have a common denominator so that you can actually subtract them. And so 5 is actually 80 over 16, and your 16s are your common denominator right here. So we know that's right. And then our denominator, which is 2 times 9 over 4. The 2 is basically 2 over 1, and when you're multiplying, you just multiply straight across, so that's how we got 18 over 4. 2 times 9, and then 1 times 4. Okay, so we know we should be set up right for now, and we do the next calculations. So as you can see, all that we have done was we took the 81 minus 80 over 16, and we got our 1 over 16, and our 18 over 4 stays in the denominator. But you know, this kind of looks nasty, and to actually be able to use it and do anything with it, we will need to clean that up a little bit. And if you remember, when you have something crazy like 1 over 16 over 18 over 4, we keep the top, we change the division sign, which is that one, to a multiplication, and then we're going to flip the bottom, so we have 4 over 18, and then we could go ahead and multiply across, but if you'll notice right down here, the 16 and 4, we can actually do something with that. We can simplify that part down to 1 over 4 times 1 over 18, because 4 goes into 16 4 times, and the 4 will just become a 1. And so there it is, all cleaned up, looking nice, and we can actually carry on with our calculations. So whenever we do that, we actually get 9 over 4 minus 1 over 72. Again, our denominators down here are off, so we need to find another common denominator. And so that's going to be, 72, since technically we just found it right up here. So we know what to multiply by. Okay, so whenever you're doing the common denominator, since we're going by 18 over 18, which is the same as 1, times our 9 over 4, and that's going to be minus 1 over 72. So that should give us 162 over 72 minus 1 over 72, and that's going to give us 161 over 72. So this one should be our x3. So now that we have an x3, don't stop there, actually go back and check it to make sure that it does come out to a 0. Okay, so we have our x3 and made a little note that we need to check it. And so how do we check it? We plug that back into the original f of x, which was x squared minus 5. So we're going to have 161 over 72 squared minus 5. And instead of going through trying to find a common denominator and everything else, you can just plug that into a calculator, and you should get something like 0.000193, and as you can tell, that is really close to 0. So that answer checks out. Thank you very much. We'll do another one next video.